And wait for it to come on. And there it goes. So we're going to go ahead and get started today and talk about 6.2. Well, let me go over again what we learned in 6.1. We always want to cover, I always want to keep them separate so you'll know what's what. In 6.1, we learned about the probability distribution. And we learned that the left-hand side was the event, which is always whole numbers. And the probability of that event happening. 0.2, 0.5, 0.2, 0.1. And we learned that there were two tests. Can anybody tell me the test? There's two tests, and we'll put them in red. What are the two tests?
All of the probabilities have to equal 1.
Yes.
And and each probability has to be between 0 and 1. Okay,
so the probabilities, each probability has to be between 0 and 1. That's the first test. And then the second test is the summation of all the probabilities has to equal 1. So we learned to do that. And we learned to find the mean and the standard deviation of the probability distribution. Mean is equal to the summation of x times p of x. And we also learned that this was called the expected value in some of the insurance and gambling questions. It's also called the expected value. And we were also told how to find the standard deviation, which is the summation of x squared times p of x minus mu squared. So that's all the information that we were given in 6.1. So what are we going to do in 6.2? Well, all of this carries over to 6.2. But in 6.2, we're going to learn how to do individual probabilities. We're still going to work with probabilities, but we're going to be asked, what is the probability of 2 or less? Or what is the probability of 1 or more? And that's the things we're going to be asked. We're going to learn how to use precise probability with the calculator, Binomial Pdf. And we're going to use the Binomial CDF for cumulative. And I'll explain that. We're also going to do this with the calculator and the Excel spreadsheet, just like we did in 6.1, to find the mean and the standard deviation. And I'm going to put technology as right there. And by hand, mu is equal to n times p, and the standard deviation is equal to the square root of npq. So technically, this is all you're going to be doing in 6.2. You're going to be doing a couple of different keys on your calculator. You're going to be doing the things that you learned in 6.1, and you're going to be doing it by hand, just using n and NPQ. And that's supposed to be a lowercase q there. And of course, Q is the complement of P. Question, gripe, complaint.
When you say Q is the complement of P, do you mean like P plus Q equals
1?
1? Okay, thought so. Thank you.
Okay. So what I'm going to do is I'm going to look at I'm going to kill 2 birds with 1 stone, and we're going to go to the homework for 6.2, and I'm just going to start working some problems while I'm doing the homework. So let's go ahead and look at some of the homework problems, and I want you to write down that. Make sure you got this written down. And of course, you already know this. And remember, most of the time, except for the probabilities for the events, we always deal with what kind of numbers? Whole numbers. Over here, the events are going to be what? Whole numbers. There's no such thing as 2.5 households. There's no such thing as 3.5 kids. Okay. Is there such thing as 17.5 flights? Can you have a half a flight?
No.
No. That'd be like half the plane showing up. I'm not talking about people. I'm talking about the plane. Can't have half a flight. You can't have half a household. You can't have half a World Series game. You can't have these things, okay? So, with that being said, let's look at a homework problem. Let me go to the handy dandy homework. And we have plenty of 6.2 problems. In fact, I think I've done all of your homework for you in one of the class recordings. Somebody sent like everybody between all the classes, y'all sent like all the homework. Now, if it was just one person doing that, I would say something. But since it's like 3 different classes sending all the different problems, it's just a coincidence that I'm pretty much doing your homework in 6.2 in one of the videos. I think I did it for 1/20/10. Yeah, 1/20/10. We like worked all of 6.2. So 6.2, 17/7. 6.2, 17/7. Go ahead and let me write this down. 6.2, 17/7. All right, this is a test question. This is a calculator question. I'm going to put calculator up here. And they're giving us, and they tell you what N, P, and Q is. N is equal to 15. P is equal to 0.65. And X is equal to 12. Now, the type of question this might be, let me give you an example. I'm going to color this example an odd color. Let's do an odd color. Let's do this, this turquoise green color. This is just for an example. You flip a coin 15 times and get 65% heads. Flip the same coin an additional 12 times, what is the probability of heads for those additional 12 times? Okay, that's the type of question that this would ask. Now you got to ask yourself, is the question, is there two answers? Yes, two solutions. What are the two solutions to flipping a coin? Heads or what? Tails. Okay, so, and does one affect the other? No. If it lands on heads, is that going to affect the next flip? No. So they're independent of each other. I did it 15 times, fixed number of times. N is equal to 15. So these are some of the things that they're going to ask you about, you know, is this a binomial distribution? Binomial meaning what? You got two possible what? Answers. Oops, sorry. You got two possible answers. Heads or what? Tails. That's what makes this a binomial instead of just a probability. So what do? Well, this is precise. This has an equal sign. There is no, this is equals. There is no less than, greater than, less than or equal to, greater than or equal to, whatever the case may be. There is no inequality. You'll see an inequality in just a minute. Okay? No inequalities. So therefore, you're going to use binomial PDF. PDF, I like to tell people, it stands for precise. Precise means equals. All right. Now, if you see one of these in your problem, and you're going to see those, then you're going to go to binomial CDF. But right now, since we're dealing with equals, you're talking about PDF. So how do you do it? Well, you go to your calculator. Let's go to our calculator. I'm just going to show you, and you write down whatever you need to write down. I'm going to clear this and clear the keyboard keystrokes. All right. To get to binomial PDF and binomial CDF, you have to type in second bars. Giving everybody a second or two to get there. Second bars. Bars is right beside the clear button. Bars. VA stands for variables. Okay. Second bars. Scroll down to binomial PDF and CDF, A and B. We want PDF for precise. Hit enter. And now type in NPX. If you have an older calculator, just stand by. N is equal to 15. P is equal to 0.65. And X is equal to 12. This is if you have a newer calculator. If you have an older calculator, it's going to look like this when you pull up binomial PDF. It's going to have a parentheses right there, and you type in 15, comma, 0.65, comma, and 12, and you close parentheses.
Can you please do?
I'm sorry, what?
Can you please do it on Excel too?
Well, you can, but I've never done it. Let's go. Let me go ahead and hit enter. 0.110 or 0.1110. So the answer here is 0.1110. I'm just going to write that down right here, 1110. Now, the reason I haven't done on the Excel spreadsheet, never had to, because everybody's always had a computer or a calculator. So I assume you can. So I will go up and look it up and probably call it binomial. So I'm going to do equals binomial, BI, and you see there's several binomials right here. I'll have to look it up right quick. Let me look it up right quick and we'll do it.
Thank you very much.
I'm sorry, what?
Thank you very much.
Mm-hmm. Okay, Excel, binomial, PDF, Excel.
Hubert, I have a quick question just about getting the answer from your calculator.
Uh-huh.
So whenever I typed in the numbers and clicked enter, it gave me an answer using like 3.5 and then a couple numbers, and then it gave me e to the -4.
That's scientific notation. I'll get to that in just a minute.
All right,
Okay.
thank you.
Return the individual terms, probabilities, binomial distribution, problem fixed, number of set, yes. I'm seeing, let me see what the CDF, there's got to be a difference between the two because, let me see what CDF. Okay, there's cumulative. Binomial distribution, XNP. It does it in a different order, XNP, but it's binomial distribution. And cum takes the value true or false. So cumulative means true. And cumulative would be false on this one. So binomial distribution, let's see if this works. Binomial distribution, I've never done this before. Binomial distribution. And they want the number of trials, which would be 15, comma, probability is 0.65, comma. Wait a minute. Let's see, hold on a second. Okay, numbers. Okay, that would be 15, and then X would be 12, and then P would be 0.65. You have to type it in a different order. And then cumulative, this is not cumulative because you're wanting it precise, so that would be false, I assume. And I didn't close it. Hold on. I didn't type in false. False, F, and enter.
Okay, so
it didn't, I don't know. I'm gonna have to get back with you on it because that's, let me hit true and see if it likes true. Okay, something's not right. I'm gonna have to work with it.
okay.
1512.65 and T. I'm gonna have to work with it and see how to do it. I've never done it like this before.
Okay.
Do you have a calculator?
I have a calculator, but I can't do this stuff with it because it's like it's more advanced than these calculators are. So.
Okay. All right. What kind of calculator you have?
It's called the TI
Inspire?
Yes.
Yeah. Same calculator. Just got a few different buttons on it for instructors and students. Same calculator, so you should be able to use it.
Okay.
Okay, I'll check this out though because I need to learn how to do it too, and I can't get out of it. I don't know why I can't get out of it. I don't want, just get out. Go away. I'll work on it and see if I can figure it out. All right, let's go back to 0.1110. That's our question. Now, Mr. Michelle brought up scientific notation. So let me show you that right quick. And where's my, there it is. And 0.1110, 0.1110. Okay, now scientific notation, y'all know how to do scientific notation from algebra. Okay, so don't let the calculator mess you up. Okay, scientific notation. If you get something that says 2.05 times 10 to the negative third power, okay, that means you're just going to move the decimal to the left 3 places. So if your calculator says 2.05 and then they got e to the negative 3 or something like that, it's the same thing. So that would be 2.05, 1, 2, 3. So this is 0.00205. So what do you have, Mr. Michelle, on your calculator?
Mine, I did like a different problem just because I was following along, but mine
That's
says
fine. Tell me what you got.
Mine says 3.5577 times e to the negative 4th.
So that would be 1, 2, 3, 4.
You have a work email.
So your answer is 0.00035577.
Okay, sweet.
Just remember, whatever this number is, if it's negative, you're going to put here, you're going to add 2 zeros. Here, you're going to add 3 zeros. And that's what I did. 1, 2, 3.
All right,
so however you want to do it. And you should remember that from algebra. Okay. So let's go over another homework question. Another homework question is 6.219/8. 6.219/8. 6.219/8. Let's see what this one says. And that first one was a test question, same question. So let's go ahead and type in. I want to show you a trick I learned in the war. This is n is equal to 20. P is equal to 0.98. And X is equal to 18. Watch this. You want to see something good? Hit second entry. And that pulls up the last operation you did. And you can just go in and change the numbers. Y'all didn't know that, did you? Some of y'all didn't. 20.98 and 18. I got 0.0528. .0528. So you got a 5% chance, 0.05. Let me put this in context. You got 20 flights, 20 airplanes, 20 flights that come in with a 98% chance of being on time. What is the probability that the 18th flight will be on time? 5% chance. And that's what that basically means. Now, they may write it a little bit different. You got a fixed number of trials. You either on time or you're not. 50-50 shot. One doesn't affect the other. When the 18th plane comes in, that doesn't affect the 19th plane. Okay, so they're independent of each other. And there's a fixed number of trials, and there's a yes or no answer, or 50-50 shot, binomial. Okay, so that should be your answer. You're going to get into some word problems here in a few minutes, so don't worry about it. Next one, 6.2. I'm sorry. How did I get to 6.2? Okay, yeah, that's right, 6.2. Okay, now I'm confused. 6.2, that was number 19. 6.2, number 27/9. 6.2, 27/9. Okay, here's your inequality. Now, I'm going to write down everything, and then I'm going to show you on the number line because that's the best way to show you. P is equal to 0.1, and X is less than equal to 4. Now, the first thing I'm going to do is I'm going to draw a number line. Remember, there's no such thing as 2.5 households. So let's say you went to 11 households, and the chance that you're watching the Olympics is 10%. What is the probability that 4 or less households are watching the Olympics? That's the type question you're going to use here. So 0 household, 1 household, 2 household, 3 households, 4 households, 5 households, 6 households, 7 households, 8 households, 9 households, 10 households, and 11 households. Okay, so somebody tell me how to graph this right here, and I'm going to mark that in pink. How do I plot that on the number line?
You would put a closed circle over 4 and then go backwards, like towards 0.
Like that?
Yes.
Why didn't I color the insides like you used to do in algebra? Why didn't I do that? Because you can't have 2.5 households. So I'm only marking the what numbers?
The whole numbers.
The whole numbers. You can't have 2.5 households. All right. So I could do this. I could do, let's see, 20.98 and 0 plus 20.98 and 1 plus 20.98 and 2 plus 20.98. I'm sorry, I did this one. Shoot. 11.1 11.1 11.1 11.1, and that would be 3, and 11.1 and 4. Is there anything wrong with doing that? Can I do that mathematically? Yes. Why am I not going to do that mathematically? Because it's too much what?
Too much work.
Okay. So how do I do that? Well, instead of using PDF, I'm going to use CDF, and CDF reads from the left hand from 0 to the number you want. That's why it's called cumulative. It always reads from 0. And which way do we read? Left to right. Masalama. Allah Akbar. Masalama. Okay? Some of y'all going, what the heck is he talking about? Well, since somebody said I offended them by saying Middle East, and they didn't know what Masalama, I started adding Allah Akbar Masalama, because that way they'll think I'm a real terrorist. CDF means cumulative, right? So I'm going to type in 11.10 and 4. And that's going to give me all of this added together. So go ahead and do that. In your calculator, do binomial CDF, which is B, and put in 11.10 and 4. Because you want 1, 0, 1, 2, 3, 4. And it measures all of these up to 4. So let's take our handy dandy calculator and do that. So second, bars, binomial CDF, 11.1 and 4. Because it does have an equal sign, it has less than or equal to. And that's what yours will look like if you have an older calculator. 0.9972. And that's the answer, 0.9972. 99% chance. Well, there's 3 good test questions. Why do I like those 3? Because they're short and what? Short and sweet. 6.2, 29/10. 6.2, 29/10. Oh, I love this one. This shows you what we're actually doing. So you're going to type in precise because you need for each number. You're going to do NP0, write that out, 4 digits. NP1, write that out, 4 digits. NP2, write that out, 4 digits, and so on. So I'm going to do this on the whiteboard so I can go back to the whiteboard and use it to type my answers in. So I'm going to draw a probability distribution. And X is going to be 0 children, or 0 girls, 1 girl, 2 girls, 3 girls, 4 girls, 5 girls, or 6 girls. And the probability of this happening with the following information. We've already had a trial of 6. And the probability came up to be 0.15 of whatever. I better not use girls or boys because that's at least 0.5. So 0.15 might be a number of games in the World Series, up to 6. You could use that. Okay, 0 games, 1 game, 2 games, or hits. How many hits does blah, blah, blah have in a single game? What is the probability that he gets no hits? What is the probability that he gets 1 hit? What is the probability he gets 2 hits? All the way up to 6 hits. Okay, so you could think of it as a baseball player's hitting average or whatever. So I'm going to do 6, 15, 0. 6, 15, 1, 6, 15, 2. 615, I'm sorry, 0.15, 3, and so on. 6.15 and 3 and 6. Now I'm going to do the first and the last one, and I'm going to let y'all fill in the middle. Okay, so y'all go ahead and be working on the middle, and I'll work on the first and the last one. So you got to use PDF because you're not doing an inequality. So second vars, and that's A, and 6.15 and 0. And enter and enter. So for 0, I've got 0.3771. 0.3771. And now I'm just going to hit second, enter, and put in 6. And I got 4 zeros, 0.0000. I'll go ahead and do 1. Second, enter. So it's not that big of a deal. You just hit second, enter, and it just pulls up 0.3993. Let's go ahead and do all of them. Second, enter, 2. 0.1762. Second, enter. Change it to a 3. 0.0415. Second, enter. Change that to a 4. 0.0055. And 5. Second, enter. 3 zeros and a 4. 0.0004. And look what we have now. We have a probability what? Distribution. Check each one. Each one is between 0 and 1. And if you add all these up, what should they equal?
1.
1. So you just made a probability distribution using NPX. So let's type them in. 0.3771, 0.3993, crap, 0.1762, 0.0415, 0.0055, 0.0004, and 0.0000. It might not like 4 zeros, but that's what it is. We feel good about ourselves. Now, I'm going to type those in the calculator. Let's go to calculator. Second, you learned this in 6.1. Stat, edit, and 0, 1, 2, 3, 4, 5, 6, and then 0.3771, 0.3993, 0.1762, 0.0415, 0.0055, 0.0004, 0.0000.
Priority 1 message coming in on secured channel.
Go to stat, calculate, first variable statistic, hit second, L2, and calculate. X bar is equal to 0.9, and sigma is equal to 0.8748. So our mean is 0.90,
You've had a work email.
and our standard deviation is equal to 0.87. Now they're saying compute the mean by hand. Okay, let's do it by hand. We know our formulas are real simple. By hand, mean is equal to n times p, and the standard deviation is equal to the square root of n times p times q. So n is equal to 6, p is equal to 0.15. Somebody tell me what q is. Somebody tell me what q is. Hurry up. Don't take all day.
0.85.
0.85. Tell the class how you got that.
You take the complement of p.
Take the complement of p. And we've been telling each other since the first day of class that the probability is equal to 1. So 1 minus 0.15 is 0.85. Therefore, I'm going to take my green highlighter, my green pen, and I'm going to do mu is equal to 6 times 0.15. And the standard deviation is equal to the square root of 6 times 0.15 times 0.85. Now I'm going to tell you a little secret. You could do this without your calculator because this is easy to calculate. All right. 10% of 6 is 0.6. And half of 0.6 is what? 0.3. So 0.6 plus 0.3 is 0.9. Somebody take 6 times 0.15 and see what you get.
I got 0.9.
It's a miracle. Now I'm going to put that 0.9, since this is n times p, I'm going to put that 0.9 right there. Let's see. 10% of 0.9 would be 0.09. 9 cents times 8, well, that's 56 cents, right? 9 cents times 8, I'm sorry,
No.
72 cents.
72 cents.
72 cents. And let's see, 72 cents, that'd be 765. Somebody tell me if it's 0.765. Square root of what? What's 0.9 times 0.85? I'll do it myself.
0.765.
765.
That's what I thought. And somebody raise 0.765 to the 0.5 power for me.
0.8746.
And there is your mean and standard deviation by hand, by using these formulas that I showed y'all at the beginning of class.
Beaver, I have a quick question.
Yeah.
So whenever I entered my points into the edit part of stat, and then I did the first variable statistic and all that, it gave me a whole number for the mean. And I'm not sure if like something was set up incorrectly.
You've got something typed in. You got something typed in wrong or something.
That's what I checked, and for some reason, like still all my variables were entered incorrectly.
Well, you should be getting, okay, let's go through it again and make sure it reads like everything. First of all, go into your stat, edit. Does these two columns say L1 and L2?
Yes, sir.
Okay, then go to stat, calculate, first variable statistic. Does this say L1 and does this say L2?
Oh, that might be what's wrong.
Yep.
I didn't have the L2.
Yep. That should fix it.
All right, sweet. Thank you.
All right, so that's going to be 0.9. And it says round to 2 decimal places, 0.87. And what does it look like as far as, let's see, skewed right? Because you got all your data to the left. So I would say B. And that is a good question. If you can do skewed right, if you can do this question right here, you can do 6.1 and 6.2. 6.2, 29 slash what? Write this down, 6.2, 29 slash 10. 6.2, 29 slash 10. You can do that one. You can do all of 6.1 and 6.2. Now I've got to shut her down because it's time for class to be over. So we got to 6.229. So I'm going to kind of delete all these 6.2s right here. Delete, 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 delete. There we go. And I will see y'all Friday, okay?
Okay.
Are you
Thank you.
taking attendance?
Oh yeah, I got to do
Thank you,
attendance.
Sarah.
Hold on. Because I didn't do attendance. All right, don't leave yet, please. All right. Let's see. Adams, Jacob, Deese. Adams. Bash is not here. Jacob and Deese. Dennis Garcia Johnson. Dennis Garcia. Good gracious, got a bunch of people not here. Hamby's not here. Harms is not here. Hernandez is not here. Hoopaw is not here. Johnson is here. I didn't see Garcia. Yeah, there's Garcia. Johnson, Jones, Noble. Johnson, Jones, Noble, Lusk, Macagina. Noble, Lusk, Macagina. Okay. If I call your name, you can go. Michelle,
Thank you.
Owen, Sanderson, Williams. Michelle, good gosh, there's a bunch of people not here. Okay, Michelle, so that means McLean's not here. Michelle, Owen, Sanderson, Williams. Michelle, Owen, Sanderson, Simmons. So that means all these people are not here. Williams is not here. Williams is here.
Owens is here.
Who?
Owens.
Owens, I got you.
All right.
I don't see Wright. I don't see Yoakum. Sanderson and Williams, are you going to leave the room, or are you away from your computer, eating breakfast, or going back to sleep? All right, well, I'll force you to leave the room.